In this video, I want to talk about proportion tests, and specifically the 1 and 2 proportion test. Now you'll notice that we are testing proportions in each of these tests. In fact, we're using attribute data. On the 1 proportion test, we're testing 1 sample, and in the 2 proportion test, 2 samples. So let's have a look at the 1 proportion test. First thing we do is construct our hypothesis statement. So I'll assume that we want to test a defect rate that's equal to 7% with an alternate of a defect rate less than 7%. Because it's less than, it's a one-tail test. I'll use a confidence level of 95%. Let's assume that I've got 200 samples that I've looked at and 4 were defective. Now clearly that isn't 7%, but again we're using this sample to make an inference against the population. So the hypothesized proportion is 7%. That's what I'm testing for, or against if you like. The z-calc is a minus 2.7 with a critical of minus 1.64. And so in this case we reject the null. Now the null says that the defect rate is equal to 7%, and we're saying no, we want to reject that, and we defer to or accept the alternate, which is in the population the inference is the defect rate is less than 7%. And alternatively, we've got a one-tail test where the p-value is extremely low versus the alpha, so we reject the null. So that's really all there is to the 1 proportion test. Now in the 2 proportion test, as you might expect, we're actually testing 2 proportions. In this example, we've got a herbal extract or an herbal extract that's not effective versus what we hope to be true, which is it is effective. So we've got a greater than, which is a one-tail test, a 95% confidence level. Let's suppose that I've got 1 sample of 150 with 88 defective, and I've got a second sample of 150 with 61 defective. And the hypothesized proportion here is, let's say it's 0. And then similarly to the 1 proportion test, we compare the calc versus the critical. And of course, whenever the calc is greater than the critical, we reject the null. And in this case, that's true, so we reject the null. So in fact, it says we reject the null, and the null said that the herbal extract is not effective. And because we're rejecting that statement, what we are concluding is that in fact the herbal extract is effective. And then also using p-values, we've got a p that's very low. When the p is lower than alpha, then we reject the null, and in fact that's exactly what we've done here. So this is just an alternate way of looking at the same thing, but the conclusion ought to be the same: reject the null and reject the null. And that's really all there is to proportion tests.